Okay, so now we're talking about adding radicals. First off, let's recall from algebra, when we have like terms, we can combine them. So if I have an x and a 2x, the variable is the same. Those are called like terms, so I can just add them up. 1x plus 2x is just 3x. In the same way, if I don't have like terms, an x and a 2y, I can't combine those, and I can just leave it like this. The same thing applies when we're talking about like radicals. So if I have like radicals, that has to be the same. They have to be the same index and radicand. In other words, it's the type of root and the number inside the root has to be the same, and then I can add them up. I can combine them. So for example, root 2 and 2 root 2. Root 2 and 2 root 2, I can combine those because it's a square root, and I've got a 2 in here, so I've got 1 root 2. You can put a 1 if you want. 1 root 2 and 2 root 2, that just makes 3 root 2. Let's see. I've got square root here, it's both of 5s. These are like radicals. I've got 3 root 5s here. I take away 8 root 5s, so I start with 3 root 5s. I take away 8 root 5s. I am left with negative 5 root 5s. So I've got like radicals again. Okay, this next little quick example, 2 root 3 minus 3 root 2. So index, I've got the same type of root. They're both square roots, but the radicand is different. This is a root 3, this is a root 2. So I can't combine this. These are not like radicals. So you just have to leave it like this. Okay, so the general idea is you have to look for the same type of root, the index, and the same number underneath the radicand. And then you can just combine it like normal. But the problems you'll see might be a little bit more difficult than that. In other words, it might take a little bit of simplifying before you get to add those guys up. Okay. So we've got that basic idea. So let's take a look then at a couple examples. So let's simplify if we can. Okay, first off, let's try the square root of 18 plus the square root of 50 minus the square root of 72. Alright, so first off, at first blush, it looks like no, they're not like radicals because the number inside the radicand is different. But we can actually try to simplify these guys. So let me take a look at the square root of 18. Maybe I can work with that. Actually, there is a perfect square in here. I could break it down all the way into 3 times 3 times 2, or I could just call that 3 squared times 2, right? 9 times 2 is 18. Same thing with 50. There is a perfect square in here. That's 25. So I could break that down 5 times 5 times 2, or I could just call that 5 squared times 2. And finally, 72. 72 is a little bit harder, so let me think about this. 72, we'll break that down. Let me just divide that by 2. So divide 72 divided by 2. Let's see, 70 divided by 2 is 35. 2 divided by 2 is 1, so 35 plus 1 is 36. Oh, there's my perfect square. So 72, I can break down into 36, which is 6 squared, and then my leftover is 2. Okay, so I could take each one out, so I'm left with 3 root 2 plus 5 root 2, because I take those out, minus 6 root 2. And now, look, I do have like radicals. I can add them up. I've got 3 root 2 plus 5 root 2. That's going to be 8 root 2 minus 6 root 2. So 8 root 2 minus 6 root 2 is just going to be 2 root 2. Okay, let's try one more example like that. So letter B, same thing. Let's do the square root of 12 minus the square root of 147. So again, it looks like I do not have like radicals, but maybe if I simplify, good things can happen. So this is a square root, so I'm looking for perfect squares. 4 is a perfect square. 4 is 2 squared. 2 squared is 4. 4 times 3 is 12, right? This is the same thing as 12, but now I can take that 2 out. Again, 147. 147 is a little bit trickier. How can this guy factor? And if you get stuck, just start listing out your perfect squares. What are our perfect squares? Well, 2 squared is 4. 3 squared is 9. 4 squared is 16. I don't think any of these go in there yet. 5 squared, 25. 6 squared, 36. 7 squared, 49. And hopefully maybe some guessing and checking is involved, but 49 does go into 147, 49 times 3, because 50 times 3 is 150, so 49 times 3 is 147. So we can break this up into 7 squared, which is 49, and 3 is our leftover. So we are going to get 2 root 3 minus 7 root 3. Now I have like radicals, 2 root 3's minus 7 root 3's. I have 2. I take away 7 of them. I am left with negative 5 root 3. And that is my simplified result.